Thanks for coming, everybody. Welcome to Working Smarter with SceneGraph. I'm Rodney Houle. I'm a senior product designer at Epic Games. So I've been with Epic Games for about 3 years now. Joined right before we launched UEFN to help with workflows, and then now I mainly work on the SceneGraph team. So the things we're going to be talking about today, we're going to go over just a quick overview of SceneGraph. We will build a prefab together. We're going to look at the new sample project we're shipping with beta. And we're going to look at a project made in SceneGraph versus using creative devices. So for SceneGraph overview, we have SceneGraph is our unified structure for connecting all the objects in our scene. It represents game objects as a parent-child tree structure, and we'll talk a lot about that today and kind of how we organize things to get the most benefit out of that. SceneGraph is easy to navigate and manipulate through Verse. So SceneGraph has 3 main concepts. Our first concept is the component. The component is the data and logic for your game. So think of like transform, meshes, particles, sound. Those are all components that we can add to our entities. Entity is a container for your components. And then finally, prefabs are multiple entities and their components grouped together in a class. So let's take a look at how we build a prefab and how all those concepts work together. So we have our scene here. We have a little trail leading into a cave. Our scene's pretty dark. It needs some lights, and we really want to draw the player's attention and lead them into that cave. So we can start by adding an entity to our scene, and when we add this entity, you'll see it's just empty besides having a transform component on it. So we'll need to add a mesh component to it, and here we'll add our light post. And so now we can add a child entity to this. And again, we can go add a component, go to mesh component, and we can add our lantern that's in our project. Now we have a very simple setup. We'll just position this lantern into place. Now, when we move our light post, our lantern goes with it because the lantern's a child. So it makes it really easy to organize things in your scene. We'll just get this popped into place, rotate it how we want. Now that we're happy with that, we can go and save it as a prefab. So here we name our prefab. And once we save this prefab, it opens in our prefab editor. So in our prefab editor, we can make changes if we want here, but we can just save for now. And now the entities that we've placed in the world have been replaced with the prefab version. So we can duplicate these out and create more instances in our world. And these are all linked to the base prefab. So you'll see when we get these positioned up, we'll start making changes and have them propagate through the world. So we can go back to our lantern and open it in our prefab editor. Now we can come in, add another entity in here. We can name these just so we know what they are. It's just a little easier for organization. And we come in and we'll add a light component to this. And now we'll get our light component positioned into place. And now once we save our prefab, all of our instances in the world are going to get this change, and it's going to propagate through all of them. So now all of our lanterns have light in the world. We update it in one place, propagates through every instance in the world. We can add another entity to this, and we can rename it, and we'll add a particle component to this. And now we have some moths flying around our lantern, and now it's starting to come to life. And again, we can reparent this to where it makes sense, and we rename our lantern. Again, we're going to save this prefab. All that change is going to go to every instance in the world. All right, so now we can add some movement to this lantern to get it to be a little more believable and have a little life in the world. So using our parent-child structure, we're creating an entity that's at the top of the lantern where it meets the light post, and we're going to animate that. And then all the children underneath it, so the mesh and the light itself is going to animate along with it. So we're using the parent-child structure to our advantage here to make it easy to just animate in one place. So I've added a custom verse component, which is called our simple mover component. And this mainly exposes the data into the details panel we can set up our animation with. Here I'm positioning the lantern to have its start position, and then I'm only adding one keyframe here to have an end position. So really efficient, really easy to set up, and just with a single keyframe we can get the movement we want. We set our duration, and we can set our movement mode, the easing mode, so we'd want this to ease in and out. So if we look at that in game, now with a single keyframe, we have it moving, the lights moves with it, so we have a little more believability to our scene. And we did it in one place, and it updated every instance that we have in the game. So if we look at the code here, I'm setting up just an enum that allows the user to select which type of movement they want. And then I'm exposing with @editable, I'm exposing some fields to the details panel, just like you would with a verse device. And then when the simulation begins, I get the keyframe movement component, which is our component that is doing all the animation. Our simple movement component here is a verse component that mainly is just data that we're feeding into the keyframe movement component. And so if we have a keyframe movement component, then we can go ahead and feed in all the data for it. But if we don't have a keyframe movement component, we can just create one at runtime, add it to the entity, and then set it all up. So we have a lot of flexibility there. You get away with, if you forget to put it on there, you get away with it because we just anticipate that and handle it correctly. And then this is just how we're feeding the data in. We can go through our enum and using a switch statement to feed in which movement mode. And then if our user has set it to autoplay, then we tell the keyframe movement component just to start playing. So we can also add interaction to our lantern using our interactable component. Our interactable component will give us an event we can subscribe to for when the player interacts with it, and it gives the prompt on the lantern. And then we have a component that handles all the turning the lights on and off. And so if we look at it in game here, we get our interaction prompt. And when the player interacts with it, the light turns off. We turn the emissive off on the mesh, and the moths get bored and they fly away. And we turn it back on, crank the emissive back up, turn the light back on. And so the code is very simple for that. We start by adding a material instance to our lantern. We find our interactable component, and we subscribe to our succeeded event. And then we find our mesh component, and we add our material instance to it. Then when the player does the interaction, we go through and we set the emissive, and we find our light component, we enable it, and we find our particle component, and we call play on it. It's like pretty easy. So now let's say we want to place one of these lanterns inside the cave. We're going to have a couple issues here when we drag and drop our new instance in. It's inside the cave. The cave's probably not going to be windy, so we don't want it to animate, right? So we can come in here. We can just remove our animation components from it, and now it no longer animates. We can just zero out our rotation on it, and now we have a lantern that's not going to rotate. Our light is a little too bright for this setting, so we can come in here and turn down the intensity. So we can do this using our override system. So these overrides are layered on top of the prefab instance. So we can go and make changes to our base prefab. This instance will get those changes, but then we'll apply any additional changes we did as overrides on top. So we still have that connection to the main prefab where we can add a bunch of different functionality or just change up what we need to for special cases. And if we look at that in game, and now our lantern is not swaying, and we still have all this interaction that we had with all the other ones, and it's still connected to the base prefab. So let's talk about how you do it with creative devices. You need to duplicate all these creative devices and have a bunch of them in the scene. So you'd have a bunch of light devices. You'd need verse devices to do the animation. You need button devices for the interactions. And all of these are just duplicated throughout the scene with no connection to each other. And when you have to change something, you got to do it in every single place. Here, everything, all of our logic, all of our data is contained inside one single prefab that we update in one place, and update it, save it, and you're done. So let's take a look at our scene graph example project that we're shipping with our beta. So all the light component example, or the lantern examples are in here. All the code that you saw before is in here for you to look at and use. And we have a few other examples we can look at in here. So we can spawn prefabs at runtime. So when I step into the trigger here, we're spawning the full prefab that has the animation, has all the interaction with it. And when we step out of the trigger, we can remove it from the world. And the code for that is pretty easy. So we have our simulation entity. Our simulation entity is the root entity of the world. So when we add something to it, we're adding it to the root of the world. And so our entities need a parent. So when you just need to add it to the world, you get the simulation entity and add it there. Here, waiting 2 seconds and then calling remove from parent. When an entity or prefab doesn't have a parent, it is removed from the world. So that's how we get rid of things. We also have collision detection now. So our cow mesh is colliding with the UFO mesh, and when that happens, we get an event that we can run some logic on. So it's pretty easy. We get our mesh component. We subscribe to our entity entered event and entity exit event, and we can run any logic we want that way. So when a mesh touches another mesh, that's when the entity entered happens. We also have, we can find overlaps. So we can find if entities are overlapping a volume. So here, using a capsule collision volume, we can determine if a cow is underneath the UFO, and if it is, we abduct it. The code for that's pretty simple, like just define a collision capsule inverse and get the transform where you want it to start. Then we go and we find the overlap, anything that's overlapping. Here, I'm just taking the first entity that overlaps with it and casting it to the cow to see, hey, did we overlap a cow? If we did, let's abduct it. And we also have ray tracing now. So here we can detect if anything's obstructing the cow. So our cows inside the dome will not be abducted, but any that are outside the domes, they can be abducted. So here we're raycasting down straight down with our mesh and just finding what we hit along the way. So really powerful, lots of use cases for this in games used all over the place. So this is great to have, and the code's pretty simple for it. So we're just defining where the sweep happens. So I'm going down 300 units. So just taking the mesh and it just pretends like if we move the mesh down 300 units, like what are we going to hit along the way? So for our sweep hit, we run find sweep hits, and then again I'm just casting to a cow, and if it is the cow, then we do our abduction logic. So let's take a look at a project that a colleague of mine, Jay Villanueva, did for an Unreal Fest presentation. So he did this project in UEFN using creative devices. So this is the Fort Vaders project, where you have invaders marching back and forth and try to shoot them down out of the sky while they shoot at you. So he shoots one down. It's a satisfying fall and explosion when they hit the ground. So very cool sample project. Lots of complexity with using creative devices with this. So first, you have multiple creative devices needed for each invader. For each of those invaders he has on screen, he has to duplicate all those devices, set them all up again. Like these invaders have 4 audio devices for each one. So there's just a lot of like duplication, and it's a big setup. The invaders are hard-coded. Their height is hard-coded. Since creative devices don't have collision detection, he needs to know how far they fall exactly before hitting the floor to play the effect. And then, so it's almost 700 lines of code for like this little example, and 200 of that is just movement code. So if we look at, let's think about like how we could do this in Scene Graph. Can we make it easier? Can we make it more extendable? Can we just make it quicker, less code? How can we do it? So first we need a way to spawn all of our invaders. And then we need to set up our invaders so they have collision detection. We can have a player ship now, and we can have that player ship fire missiles. So our invader manager is a prefab that spawns our invaders as nested prefabs. So you can have as many layers deep as you want of prefabs inside of prefabs. So this is super handy for just being able to manage everything. Then our invaders need to animate. So if we march them back and forth and move them down, we're only moving the invader manager, that's the parent. And we only move one entity here, and then all the children just move along with it. So we only have to do that animation in one spot for moving them left and right and down. So for the code for that, this is how we spawn the invaders. We just loop through and then spawn the number of columns and rows that we need. And again, add them to the invader manager and set their transform. And all these fields are exposed in the details panel, so we can quickly tune how many we need. If we want 20 invaders, we want 5 rows, 6 rows, we can just change that up, where if you were to do this with creative devices, you're duplicating a bunch of stuff in the world or deleting stuff, so this is a lot more manageable, easier, and quicker to do. So our invaders, they need to have collision detection. They also need to animate, and they have to explode when they hit the ground, and then they're going to remove themselves from the world when they're dead. So this is the method for when the invader gets hit by a missile. We get the simulation entity, because now we're going to, instead of being a child of the invader manager, we need to reparent it to the simulation entity so we can animate it independently of the, so it will no longer march back and forth. It needs to animate falling to the ground. And then we get our VFX component and sound component, so you get some feedback when they're hit. They'll play a particle and they'll play a sound. So to get them to fall to the ground is super easy. I just set one keyframe that moves them down, and then get the keyframe movement component and just call play on it. So for our player ship needs to move left and right, and it needs to fire missiles. pretty simple. So with Scene Graph, we now have access to the movement tick. So we have access to tick events and delta time. So we can smoothly translate the ship left and right. The important thing about this one is just using local transform, because we can spawn our ship anywhere in the world and we don't care, and it will still work because we're just translating it in local space for it. And then we get a child entity from the player ship, and that is just an empty entity that only has a transform component on it, and we use that as it's at the top of the ship, so we use that transform to know where to spawn the missile from. So it's spawning from the top of the ship, and then we spawn our missile, we add it to the simulation entity, we set its transform, and we play a sound when we fire. So our player missile is really easy. It just animates going up, and it has collision detection. So we get our mesh component here, and we're waiting for the entity entered event. So here we're just waiting for that collision to happen. So like that code will just wait for that. And then once that collision happens, then we call the logic for the missile hit, and we remove the missile from the scene. We also have a floor. It's just a plane that's invisible, that's just there for the collision detection for when an invader falls, hits the floor. We can get that entity entered event from the floor. So taking a look at it all together, we can move our ship, we can fire our missiles, our invaders are marching back and forth, we hit them, they fall to the ground. They can be any height, we don't care. Like, we can just wait for that collision event. Then when they hit the ground, they explode. And then like with our animation on the invader manager, we can speed them up and do whatever we want. That's really, really simple, really quick. To do. That was a lot less code and like 5 prefabs and a few components, right? So to wrap up, building with Scene Graph is more efficient when leveraging components and prefabs. Collision detection unlocks new gameplay possibilities. By reducing device duplication, Scene Graph streamlines workflows and lowers the risk of mistakes. Beta, June 7th, please try it out and give us feedback. Yes, I mean, we're all excited. It took way too long, but that's it. If like anybody has any other questions, I'll be at our UEFN booth, so feel free to drop by and come ask questions. Thank you all.